looking at today in 1.4 is kind of dealing with perimeter area and mainly polygons. Polygons. Now, a polygon is a geometric figure. So in geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more lines, segments called sides. Each side intersects exactly at 2 sides. One at each vertex, so that no 2 sides with a common vertex are collinear. You can name a polygon by listing the vertices in consecutive order. So what is it? It's a closed figure. A polygon is what? It is a closed figure with 3 or more sides. It's a closed figure with 3 or more sides. That's it. The rest of it is kind of more of a mathematical explanation of what it is. But really, a polygon is a closed figure with 3 or more sides. Now, where those sides meet, they meet at a vertex. A vertex is the point where 2 segments meet on a polygon. It's called a vertex. Okay? Now, we're going to have to say 3 or more, because again, since it is a closed figure formed by line segments, can line segments bend? Can we have them curve? No. So if I had, well, I can draw 2 lines, yes? Will those ever come back together and make a closed figure? No. So that's why we have to have 3 or more. Because the only way for these 2 to actually be a closed figure would not be lines. We almost have to talk about curves. We'd have to have curved lines, which we will not do. So a polygon is a closed figure with 3 or more sides. Now, if you notice at the end of that, you can name a polygon by listing the vertices in consecutive order. So you almost pick a spot and then go around. So Shani, pick a vertex up there. D. So I can name this starting off with the letter D. Someone give me another letter. So once I pick the next one, because really we only had C or E, so we went D, C, yes? Have to follow that path. So the next one would be B, A, E. So we call this polygon DCBAE. And that's it. Now we could have gone the other direction and said DEABC, and that'd be another way to name it. So once you pick a starting letter, you're going left or right. You should go around the figure. We can't jump. I can't go ADBCE. It has to be along the figure. You got to go one direction or the other. So in naming it, you're really just picking a starting point and going around. Questions on this here? Okay. Now, that's one way to name it, is just based off the letters. The other way we can name it is based off the sides. Now, the least number of sides we said was what? What do we name a 3-sided polygon? It's a triangle. I'm going to go on and show you the numbers because these are all the numbers we're going to look at. This is also in your digital textbook in chapter 1.4, this whole table. Pretty much, and they're also on the note sheet. So this here, this table is in the book. Most of the problems come straight from the book. Does anybody have a guess at what a 4-sided polygon would be? Quadrilateral. A quadrilateral is a square. So quad means what? Four lateral, 4-sided figure. So a square, a rectangle, a rhombus, a parallelogram, a kite are all different 4-sided figures. But those have trapezoid. Yes, thank you. because that's one I forgot. I knew I was missing one. They're all different four-sided figures, but they have special properties to them. This here is just any four-sided figure. If it has four-sided, it is at least a quadrilateral. But when we get more specific information about it, so if we know all the sides are the same length and they have right angles, then it is a square. So when we get more information, then we can be more specific. But at least a four-sided figure will be a quadrilateral. A 5 is a pentagon. Pentagon. 6 would be a, 7 is a, $12 is a dodeca. $11 is a an undecagon. Undecagon is 11. And n, for any n side really greater than 12, we call n gone. N just being the number of sides. So 13 would be a 13 gone, because you'd write 13 dash gone. Just whatever it is, gone. Did you guys hear what happened to the polygon when it ran away? It was in gone. You don't have to humor my jokes. My wife doesn't either. She just rolls her eyes and acts like it didn't happen. Mm-hmm. Actually, I make bad punny jokes pretty much all the time. Do y'all know where Flint Ridge is?
Yeah.
Yes? Yeah. Y'all know where the airport in Siloam is?
Yeah.
You know the distance between the two? Or going from the airport pretty much all the way to Little Kansas down to Flint Ridge, that distance? We saw a little, like a 4 doors, like a Civic, kind of small car. The back end of that car had to have been 2 to 3 feet lifted, just the back end. Made no sense. I made that level of jokes from when we saw it next to that airport all the way to Flint Ridge. My wife wanted to slap me. So that's about a half hour of those jokes, one after the other. So are there any questions on these here? These here would be good to know and kind of remember, because when we start talking, especially when there's a whole chapter dealing with polygons, it's not going to be talking so much about a 5-sided polygon is a pentagon, so it's going to be in the figure. When we're dealing with a pentagon, they're going to straight up use these names. They're not going to tell you, well, it's 5-sided, so the pentagon. No, it's knowing these is good. Pentagon is going to be 5. It's the following decagon has these properties. We need to know these. Yes.
Wouldn't another 6-sided be a sexagon?
It wouldn't. We normally stay with pent. Because 6, that's normally used in a different way. So any questions on these here? We good with these here? So let's name this polygon here. So we can call this what? Polygon And we can go either way, yes? I mean, there's, how many letters here? 1, 2, 3, 4, 5, 6, 7. There's 14 different ways to name it using the letters. Because each letter has 2 directions we can go. There's 7 of them. Each one has 2. 7 times 2 gives us 14. So there's 14 different ways to name this based off our starting point. What is another name we can give this? So not using the letters. Because how many sides do we have? 1. So 7 sides is what? So we're not using the letters. So side. It's a heptagon because we have 7 sides. So we could go through it and list all the different ways to use the letters to name it, but I'm not going to because that'd take a while. And I feel like y'all have a good understanding using the letters to name it, yes? You pick a point and go round, one direction or the other. So how about the letter B? RSQMNKP. How many sides do we have? 8, so it's a octagon. And that's it. Any questions on naming these two here? We good with naming these based off the sides and the lettering? Yes? Okay. So this is our next slide, yes? We're going to move on to this one. So just turn the page. The reason I do that is because I really need to reorder these slides, but if we understand concave, we will understand convex. Concave is going to make convex make more sense. You can write all this down, but let's look at it. A polygon in which at least one line that contains a side of the polygon contains a point in the interior of the polygon. How many of you are confused with that? Yes? What it's saying, so a polygon, at least one line contains a side. So if it contains the side, it's a part of the side length, yes? That's what that first part is saying. And contains at least a side of the polygon contains a point in the interior of the polygon. So if one of the lines, we take one of the sides and extend it out indefinitely, we turn it into a line, and it contains a point inside, it goes inside the figure. If we extend one of the sides and it goes inside the figure, then it is concave. If you extend one of the sides and it goes inside the figure, then it is concave. It caved in. It goes inside. The line, when we extend it, goes inside the figure. So does this make sense here? Yes? Concave, it's, if we extend the side, it goes inside the figure. Kind of like this here, where you see this line goes inside of it. It is concave. Questions on this here? Careful, it's convex. Yep. So we good with convex, yes? Or non-convex, concave, yes? Yeah. Okay, now I'm going to back up and we're going to look at convex. A polygon in which no line that contains a side of the polygon contains a point in the interior of the polygon. Convex. If it's not, pretty much, it's not concave. Because what did we say about concave? If I can extend one of the sides and it goes inside the polygon, it's concave. This is saying if I extend all the sides, none of them should go inside. So a way to think about this is, can I extend a side and make it go and it ends up inside the polygon? No, it's convex. So really, we've got one of two options. You can really check to see, is it concave? Well, if it's not concave, then it has to be convex. There's no third option. It's one or the other. So you could write concave. It is not convex. Or so convex is not concave. Because I've seen that understanding what concave is makes sense. Convex is just anything that is not concave. Questions on this here? Let's actually look at one and see. So looking at letter A here. So this is underneath concave. Would we call this convex or concave? Concave, because I can extend these two sides, yes? Because if I extend this side here, it goes straight through. It cuts part of it off, yes? So this here is concave. But we also want to classify it by the number of sides. How many sides does it have? So it's a quadrilateral. Because it has four sides, it's quadrilateral, and because we can draw a line that cuts part of it off, it is concave. How about this one here? Because it's not concave, is it? There's no way I can cut it. Now, how many sides do we have? So it's a that's it. Now, if it doesn't give us any lettering on the vertexes or the vertices, we can't name it based off the letters. We can only name it based off the sides. Questions on this here? We good with this here? Yes? How many sides do we have? 5, so it's a pentagon. It is. Is this line or this line will cut straight into the figure. How about the next one? So if you have trouble counting the sides, sometimes what I'll do is I'll make a little mark for myself to remember where I started when I count around. So 1, 2, 3, 4, 5, 6, 7 is a heptagon, and it would be convex because there's no line that I can extend from the sides that would cut into the middle of it. Questions on this here? We good with everything so far? Area, perimeter and area. Perimeter is what? Perimeter is adding all the side lengths together. So we add all the side lengths together. So for a triangle, their perimeter would just be, for here, A, B, and C. For a square, they're going to call it 4S. Because how many of the sides do we have on a square? And they're all the same, yes? So saying S plus S plus S plus S is the same as saying 4S. In a rectangle, the perimeter is equal to twice the length plus twice the width, because we'll have two of the same sets of sides. Questions on any of this here so far? What's the area formula for a rectangle? It is length times width, yes? A square is the same thing. You can do length times width or S squared, because since S, the sides of a square are the same, saying S squared, the side length squared, is the same as saying length times width because they're the same measure. And the area formula for a triangle is 1/2 base times height. Any questions on any of these here so far? So you guys have all these formulas written down? Because you will need them. And it'll be a good reference to have them. We good? Find the perimeter of ABC with vertices -2, 3, 3, -3, and -2, -3. Hopefully I already have this down. Yes, no, I might have forgot to erase it. Now you don't have to have the graph to find the perimeter. Because again, the perimeter is just the side lengths, the distance of each side added together, yes? So from A to C, C to B, and B to A, we're adding these all together. Now, having a graph does help because as we see here, AC and BC or CB are on a straight line, aren't they? Yes? So if we have them on a graph, it makes this kind of easy because what I can do is I can come up here and go 1, 2, 3, 4, 5, 6. I can count straight down because it's all going by ones, and we can just count it straight down. Now from C to B, we can do the same thing because it's going straight across. 1, 2, 3, 4, 5. Not too bad so far, is it? Can I do the same thing from A to B? No, it's a diagonal, isn't it? So we're going to have to use the distance formula. Really, for any of these here, we could have used the distance formula. And for a triangle, we're going to have 3 sides, so we could have found the distance from A to B, A to C, and then B to C. Use the distance formula for all 3. And we would have gotten our answers. Now looking at this distance formula, so we're going from A to B. What are our 2 x values for A and B? So we have -2 minus 3 squared. Our y values are 3 and -3. Now what do we do next? Yeah, you can just type this into the calculator. The calculator will do this for you. You can do square root, parentheses, -2 minus 3, close parentheses, squared, plus parentheses, 3 minus -3, close parentheses, squared. Type it all in. If you have trouble with simplifying this, just type it in as it is right there. And the calculator will tell you exactly what it is. Now, if we do this by hand, 2 minus 3 is -5. A negative and negative will make a positive, so that gives us 6. -5 squared is 25. 6 squared is 36. 25 plus 36 is 61. What is it? 25, 36, 49, 64. So our hypotenuse is the square root of 61, and I believe it does not reduce. Now, if it's asking for on the homework, and I'd be making sure to pay attention to the wording, because if it says it wants the exact length of the perimeter, we are leaving it as the square root of 61. Because the square root of 61 is the exact length. Now, again, perimeter is adding all the sides together. So what are our side lengths? 6, 5, and the square root of 61, yes? What are our like terms? Because there's 2 of them. What are they? What is 6 plus 5? Can I combine 11 and the square root of 61? No, they're different terms, aren't they? So what's our perimeter? 11 plus the square root of 61. And that's it. That is the perimeter of this figure. I don't know for sure if the homework will have graphs for you. If they do, that would be great. If not, again, we're just going back to the distance formula. Distance formula. Questions on this here? And I believe the scientific calculator that's on Big Ideas Math will let you do this, yes? Not too hard to put that in? Okay. Any other questions on this problem here? Or any questions on this problem? All was asking for the perimeter. Find the perimeter of the polygon with the given vertices. So this is our next one here, yes? Well, probably you notice this triangle hanging out down below. Almost. There we go. Move it up there. Thank you. So I put it in there just as a cheat so I can move it up there. But this is our triangle because 3 points, 3 sides give us our triangle. Now, unfortunately, you don't have the triangle kind of drawn in, but you can count from, because 2 of those sides are straight on an axis, yes? Because D to E is straight across, so we can go count. 1, 2, 3, 4, 5, 6, 7. I'm not going to count the little squares because the little squares actually aren't 1. It's kind of the darker lines that are 1. So D to E is 7. Well, E to F, again, is straight line. We've got 1, 2, 3, 4, 5. What's the only one we don't know? This one here, right? From D to F. D to F is the only one we don't have. So guess what we have to do? Distance formula. We're using the distance formula again. So again, we're going to need our x values. Well, the x values for this are what? Yes, it would be -3. So 3 is negative. And then -3 and 2 squared. And again, at this point here, you could type all of this in the calculator just like you see it, and it will give you the answer. It'll tell you what it is. Or if you do it by hand, like I do it most times, -3 minus 4 is -7. -3 minus 2 is -5. Well, -7 squared is 49. -5 squared is 25, which will give us the square root of 74. Which I think is just the square root of 74 because that doesn't reduce. Yep. Any questions on how we found our 2 sides? Or 3 sides, actually. Sorry, 3 sides. Now what do we need to do to finish this? We're going to do 7 plus 5 plus Well, I can add 7 and 5 and I get what? 12, yes. Plus the square root of 74. 12 plus the square root of 74 would be our perimeter. The distance around the figure, around the shape. Questions on this here? We good with this here? Yes? So this is the next one we're going to look at. Well, this is just hiding. So we have this here. Our 3 points. How many of these are on a straight line? How many of these sides are on a straight line? 1. So we can go on and count that one. So we've got a distance of 1, 2, 3, 4. Now we need to find what the distance from G to J and H to J. We've got to find both of those. So that means we're using the distance formula twice. So which one do we want to find first? G to J or H to J? We're going to have to find both. We just need to find one first. G to J. So what are our x values for this here? We have -3 minus. Then our y values would be 2 minus -3. And we could rewrite that as addition, or you can leave it as a negative negative. And again, I would type that straight into the calculator. You don't have to simplify it down. You can just type it straight in. Or if you're like me and want to handwrite each step, you can. Squared plus 5 squared. -2 squared is 4. 5 squared is. So we get 29. This here is the square root of 29. Now we need to do this one more time. So I need, H to J. So what are our x? So we'd have 2 minus -1. Yes, thank you. I was looking at G. I was looking at the wrong one. Let's make that work. There we go. 2 -1 plus 2 minus -3. And then we can plug this in to the calculator. So 9 plus. And you should get the square root of 34. Yep, we got to do it twice. Now we just add all of them together. So our 3 lengths are 5, square root of 29, square root of 34. So what would be our like terms? Is the square root of 29 the same thing as the square root of 34?
No.
So if it wants exact solution, exact length, we would just have to put this here. If it wants approximate, a decimal, and it'll tell you how many decimal places, we would type it in. Because the approximate is 16.22 units if it wants approximate. If it doesn't, we just leave it with both square roots. Questions on this here? Any questions on anything we've done so far? No? All right. We're going to stop there. We're going to stop there. We're going to pick this up tomorrow. We don't have too many more. I think we have one more perimeter and then some area. And then we are done.